And hello once again, and we're going to go through chapter 6.2 on similarity, page 165 of your Discovering Mathematics textbook 2A. Okay, just a simple illustration on similarity. If you look at the green triangle and the red triangle, they are congruent. They are exactly the same, same lengths, same corresponding lengths, same corresponding angles. So for similarity, what happens is this. If I take this tool, okay, the lasso tool, I will take, okay, so just to show you that they are exactly the same, okay, I put it down. All right, so they are congruent, okay, exactly the same. So now what happens here is this. I'm going to just enlarge, right, the red triangle. So now the two triangles, they are not congruent anymore, okay, but what happens here is this. They are similar, okay. So for similar triangles, right, they have the first thing that we notice is they have the same angles, okay. So if you look, right, this angle is the same, this angle is the same, this angle is the same as well. All right, so now the next thing about similar triangles is this, that the order of vertices matter. So just like congruency, I explained to you all before about the order of vertices. So if I say that ABC is similar to PQR, so how do I know that how do I know the order of vertices? One thing that I tend to look out for is the angles. So you look for corresponding angle. A corresponds to P, angle B corresponds to angle Q, and angle C corresponds to angle R. So therefore, what we can say is that triangle ABC is similar to PQR. So down here, ABC is PQR. So you notice that since the order matters, so ABC must be PQR. It cannot be similar to RQP. So just try, okay. For example, if I wrote triangle BAC, so it is similar to triangle QPR. Okay, in this case, this statement is correct. Well, that statement was wrong. Okay, so the order of matrices actually matter. Okay, now I also need to give you a certain idea of similarity. There's a scale factor. So for example, in the first case, I had the two triangles. I enlarged one triangle. So in this case, similarly down here, I've enlarged the red triangle. So when we enlarge a triangle, these two triangles, the green triangle and the red triangle, they are similar. And there will be something called a scale factor. Okay, what is a scale factor? If you notice, like if this length is 3, okay, proportionally this length is 6. So if this length is 7, then this length is 14. So the scale factor is, what we take is, we take 6 divided by 3 is equals to 2. Okay, so the scale factor is 2. So how to use this scale factor? So for example, okay, if I gave you that this length over here is 5.5, can you predict what this length YZ will be? Because the scale factor is 2, I know that this length will be multiplied by 2 and YZ will be 11 cm. Okay, just another practice on scale factor. It's not always what I call a number larger than 1. Sometimes it can be a number smaller than 1. This occurs when actually the figure, it becomes reduced, okay. So in this case, XYZ is reduced to ABC. So can you predict the scale factor? So in this case, the scale factor is equals to 3 over 9, or also can take 6 over 18 is 1/3. Okay, so just to illustrate that, so just imagine that if this was, let's say, if this side YZ was 15 cm, since my scale factor is 1/3, I know that this length here will be 15 times 1/3. I can predict that this will be 5 cm. Okay, now, so if two triangles are similar, as we have proven, all the corresponding angles are equal, and the ratios of the corresponding sides will also be equal, as I've shown you from the slides on scale factor previously. Alright, similarly for two polygons, if two polygons are similar, all the corresponding angles will be the same, will be equal as well. So angle D will correspond to angle S, angle A will correspond to this angle P, angle C will correspond to R, and angle B will correspond to angle Q. Now I'll just dive into some questions. Okay, so first I'm on page 170. Okay, we have try it too. So first they ask you what is the angle ABC. So since they are similar triangles, they must have the same angle. So angle ABC is equals to 113 degrees. Okay, then these are corresponding angles of similar triangles. Now I move on to part B itself. Okay, we know that the lengths, okay, should be proportional. So if I want to find BC, okay, BC in this case will correspond to YZ. So it's BC over 5 will be equals to AB over XY. Please don't use AC over XZ because you do not know the values there. So in this case, I will say is AB over XY. So my BC value is equals to, and simply BC is equals to 3.75 cm. Okay, now we are on try 3. It's on page 171 of the textbook. So you may like to pause the video to actually turn it to the appropriate page. So now we are trying to find angle PQR, the corresponding angle for PQR in this case. Okay, let me teach you a trick here. So the vertices are given, okay. So the vertices will already be in order already. So sometimes if you can't find the angle, what I can do is I use a question to help me. So I just, okay, let me try to make it bigger. So I just label them 1, 2, 3, 4, 1, 2, 3, 4. So if angle PQR, okay, so it's 1, 2, 3, okay, 1, 2, 3. So the corresponding angle will be angle ABC. 1, 2, and 3. So similarly, okay, if for example, okay, the question asks you for QRS. So QRS is 2, 3, and 4. The corresponding angle will be angle BCD, which is 2, 3, and 4. Similarly, this idea even works with corresponding sides. So for example, if I say BC, which is number 2 and 3, down here, 2 and 3, the corresponding side will be QR, which is 2 and 3. Okay, it's not equal, okay, it's just at the corresponding side. So BC will correspond to QR. So just a quick one, if I say I want the corresponding side to CD, CD will correspond to RS because it's 3 and 4, 3 and 4. So with this knowledge, PQR, the corresponding angle to PQR will be angle ABC. So what we'll get here is 83 degrees. So for part B, now we want to find the length of AB. So I put AB on the top left. So AB, okay, 1 and 2 will correspond to PQ 1 and 2. So I say AB over PQ will be equals to AD. Why did I choose AD? Because there's a value to AD, which is 16. So AD, the corresponding side will be PQ. Sorry, it's not PQ. AD, the corresponding side is PS. So what we have is AB over 25 is equals to 16 over 20. Solving, times 25 on both sides. AB is equals to 20 cm. Now for part C, alright, same idea as we did, so just make it go quicker. QR over BC is QR over 25. Okay, I think I made a mistake somewhere, just give me a moment there. Okay, so what we have is QR over BC, okay, which is equals to, maybe I will use 20 over 16. I use the PS over AD. Okay, so QR over BC, so it's QR over 25 is 20 over 16. So QR value is equals to 20 over 16 multiplied to 25. QR value is 31.25 cm. Exact value, so please don't round it off. Okay, now I give you examples from exercise 6.2. You can turn your textbook to page 173 and I will carry on with question 2. So, are the corresponding angles of ABCD and PQRS equal? Yes, they are, because a square, all the angles are 90 degrees, a rectangle also. So I say yes, okay, all angles are equal to 90 degrees. Now for part B, is AB over PQ is equals to BC over QR. So I find that AB over PQ is equals to 3 over 6. It is half. Then but BC over QR is 3 over 3 is equals to 1. So therefore, no, they are not equal. Okay, for part C, is ABCD no similar to PQRS? I can say that since the corresponding sides are not in proportion, ABCD is not similar to PQRS. Okay, now I'm on question 4, also of exercise 6.2. The diagram shows two similar triangles. So actually what I can say, which are the angles that are corresponding. So if I just take a look there, they want me to find what corresponds to BAC. So BAC will actually correspond to QPR. So I just write it down. Angle BAC will be equals to angle QPR. Okay, note the order of vertices matter. So part 2. Now they say ACB. Okay, ACB is here and here, the angle in red. So angle ACB is equals to angle PRQ. So state the pair of similar triangles. Just use the colors to guide you actually. So I'll say that triangle ACB is similar to triangle PRQ. Okay, I will now cover one last question, 6B, from exercise 6.2, and then this will be the final question, after which you may try the homework on class kick. So now for 6B, find the values of the marked unknowns, okay, in the pairs of similar triangles. So first and foremost for 6B, let me state the similarity. So triangle GHK is similar to triangle LMNN. So in this case, okay, they actually stated that for me already. Okay, my bad. So now, so angle G, okay, will be, okay, angle HGK, the order 2, 1, 3 is equals to angle MLN, which is equals to 38 degrees. So now on my diagram, I can note down that this is 38 degrees. Hence, okay, X is equals to 180 minus 38 minus 75 degrees. It gives me 67 degrees. Then final for angle y is angle L and M. So okay, L and M is 132. So L and M is equals to angle G KH. So in this case, the angle is equals to 75 degrees. Hence, I say that y is equals to 75 degrees.